Hi friends, welcome to the very first episode of my Statistics 101 series. Whether you're a total beginner, just curious, or feeling a little lost in class, you're in the right place. This is Easy Econ, and I'll be walking you through statistics in the simplest, most fun way possible. So grab your notes or just relax and watch. Okay, so before we jump into the exciting stuff, we need to understand some basic terms, which you may or may not have heard of before. First up, we have population. This is the whole entire group that we are interested in. For example, it could be all students in your whole school. Another example could be, say, the entire adult population in a certain country. Next up, we have sample. This is just a subset or a small part of that whole population. For example, it could be just one class or one specific class in your school. Now let's say there are 500 students in your school. This would be the population. Now a sample would be, say, just one class in your school, which could be, say, 30 students. Moving on to the next key definition, we have parameter. Now, parameter is a specific characteristic of the whole population. For example, it could be the average height of all the students in your school. So, parameter here is a specific characteristic of the whole 500 students in your school. Next, we have statistic. Now this one is a specific characteristic of the sample. For example, it could be the average height of just the students in one class. So statistic in this example would be just a certain characteristic of the 30 students in your class, for example, which is the sample. So why do we use samples? The reason is that working with the whole population is usually hard and impossible. Let's say you want to check the average height of everyone in the US. That will be very time consuming and expensive and is more or less impossible, right? So instead, we use a small group to guess things about the bigger group. And that's what statistics, particularly inferential statistics, which I'll talk about in a bit, is all about. Alright, now that we know the key players or definitions, let's meet the two big branches of statistics. First up, we have descriptive statistics. Now this one simply describes what's going on in the data that you have. As per the name, descriptive statistics. So you're not making any predictions or estimations, you're simply stating and summarizing the data that you have. For example, when you hear people say, in a sample of, say, 100 individuals, 36% think watching TV is the best way to spend an evening. So that's simply describing and stating or summarizing the data that you have obtained. So you're mostly dealing with past instances. Now the second one, we have inferential statistics. Now this one uses the sample data that we have to make predictions, estimations, and draw conclusions about the whole population. So if we're sticking to technicalities, which are the key definitions that we've mentioned before, in inferential statistics, we use the statistic from our sample to make a smart guess about the parameter. Or in other words, using what we currently know about a small group to learn something about the big group or the whole population. Now there are actually two ways to make inferences, and I'll explain these shortly. Now let's zoom into descriptive statistics, starting with something called the measures of central tendency, which is actually just a fancy way of saying what are some important or typical values of our data. So first we have mean, which is just the average. So it is the observed values divided by the sample size n. So let's say we have a range of values, say x1, x2, x3, x4, and so on. The average of these values would just be summing all of them up and dividing them by the number of observations there are, which is n. This is equal to just saying, say, the summation of x's divided by n. This would be the average. And this one is rather straightforward, and I think all of you might already know this. Moving on, we have the median. So this is just the middle value in a sorted list. So again, let's say we have a range of values. And let's assume that these are sorted from lowest values to largest values. So if the number of values is odd, such as in this case, the median would just be the middle number, which is x3. However, if it is even, let's say we have 6 values, then the median would be the average of the two middle numbers, which would be x3 and x4. So the median would be equal to x3 plus x4 divided by 2, which is just the average of these two numbers, x3 and x4. Now in the case that you have, say, a large number of data or a large number of values where it's not so straightforward to see the median, there's actually a formula to know the position of the median number, which is the sample size plus 1 divided by 2. So this would help you find the median position. So say we have 50 values. So the median would be this in this position in the sorted range of data. You just sort out the data and you can just find based on the position what is the median number. Alright, next up we have mode. Now this is the value which occurs most often in the range of values. Alright, so these help us to understand what is normal or typical in our data. And so it's called the measures of central tendency. Next up, measures of dispersion, or a fancy way of saying how spread out is our data. For example, do students in your class all score about the same on a test, or are some students getting 100 and the others 20? So that's where these measures come in, which are just different ways of telling us how spread out is our data. The first one, which is probably the simplest one of them all, is range, which is just the difference between the highest and lowest observation or values. So it's just the maximum value minus the minimum value in the range of data. The second one, we have interquartile range, or the IQR. This one is rather a little bit more complicated compared to range, but what it does is just measuring the spread in the middle 50% of the data. So what it does is it splits the sorted data into 4 equal segments. So let's say we have a lot of data values here. So IQR, what it does is that it splits them up into 4 equal segments, as I've mentioned, and it finds the values of the data points in the first, second, which is just the median, and third quartiles. Then it calculates the IQR, which is just the difference between the values in the third quartile and the first quartile. So it's just the difference between this value and this value. So essentially, what we're doing is we're measuring out this range here. Now, what we discussed with the first one, range, is that it measures the difference between the maximum and the minimum. So it essentially finds this, while the interquartile range is designed to basically disregard any outlier values in case if there are any. So outlier values, or say extreme values, would typically be located around these areas. So what interquartile range does is that it measures the spread only in the middle 50%, which is just between the first and the third quartiles. Alright, moving on, the third measure we have is variance. So variance actually looks at, on average, how far each data point is from the mean. I'll go into variance a bit more in my next videos, but just take it as how it is right now. And the fourth term is standard deviation. Now this is something you'll encounter a lot in statistics. It is just the square root of variance. So it tells us in original units how far on average the data point is from the mean. So it is basically telling the same thing as variance, which is just how far each data point is from the mean. However, standard deviation tells this in different units compared to variance, which is just in original units. I'll have a separate video going into detail about these two important terms, so stay tuned for that. Now let's proceed to inferential statistics and look at the first part, estimation. Now let's imagine that you want to know the average height of all students in your country. Now you cannot really measure the height of every single person or every single student in your country, right? So instead, you measure the height of students in a sample. Let's say the average height of everyone in your own school, and use that to estimate the average for the whole country. So let's say if the average height of students in your school is 160 centimeters. From this information, you could estimate the average height of students in your whole country to be somewhere around that. But of course, how accurate is that? Because your sample might not be representative of the whole school population in the country. Now that is something that we will learn more about later. But for now, it's important for you to understand that what estimation does, or what estimation is about, is simply using information that you have about a sample to estimate the actual information about the whole population. That's basically what estimation in inferential statistics is all about. Now, there are two kinds of estimation. First, we have point estimation, which is just a single best guess, or using a single number to estimate an unknown population parameter. But of course, real life isn't always that exact. You can't just have one number, as I've mentioned before, say 160 centimeters, to estimate the actual average height of all students in your country. And this is because there's always some uncertainty, and that's where the second type comes in, which is the confidence interval, or the interval estimation. So instead of just giving one number, say 160 centimeters, we say that the true population average is probably somewhere around 158 centimeters to 162 centimeters. So that's called an interval estimate. You're giving a range of values that you believe the population parameter falls into. We use the confidence interval method to calculate the exact range. The second method to make inferences is hypothesis testing. Now this is like a yes or no test for a claim that we want to test. So we usually start with something called the null hypothesis, written as H0. Now this is like the default assumption. Then we test it against the alternative hypothesis, written as H1. Now this is the new claim that we want to investigate. And what you need to remember is that it is always the opposite of the null hypothesis. Now, using the same example, if we found that the average height of students in your class is 160 centimeters, then our null hypothesis, which is H0, would be that the average height of students in your whole school, which is the population average height, is also equal to 160 centimeters. So we always assume the null hypothesis to be that the population parameter is equal to the sample statistic. This is the null hypothesis that we are trying to test. So our null hypothesis would say that the population average height is equal to 160 centimeters, which is actually our sample statistic. And the alternative hypothesis, H1, would say that nope, the population average height is not equal to 160 centimeters. So you see how it's always the opposite of the null hypothesis. So it's actually quite easy, quite straightforward to draft out the null hypothesis and the alternative hypothesis, especially if you already know what the null hypothesis is. So that's all for the Introduction to Statistics 101 video. Hope you like it. Subscribe. This is Easy Econ, and I'll see you in my next video. Bye!